This is the video for class 12th and the chapter which is going on is electromagnetic induction, and the topic which we will gonna deal today is motional EMF. Okay. So motional EMF means what? Movement of any conductor and the EMF which is attached to it. Okay. So basically if we have not studied this topic yet, so we will whatever the knowledge we will get from the topic is this. Motional means due to a motion, and the EMF generated due to a motion. So basically we will study about the motion of a conductor and the EMF generated due to that. So for this reason, first of all, we let me give you the synopsis of the topic which we gonna deal. Okay, suppose there is a magnetic field lines in a region. Okay, and we have taken a conductor which is of having of length L, and it is supposed that in a region it is moving in a with a velocity v. We have taken a rod which is in the conducting nature. Now, what will happen if B is kept constant? Now, if we are not changing the magnetic field lines in that region, so if in the future the magnetic field lines generates, or means sorry, the EMF generates and induce current. So first of all, that current will not be because of the change in the magnetic field lines magnitude. Okay, so from where that EMF will come then? Now, EMF will come due to the motion of the conducting rod of length L. The EMF which is gonna generated, or the current which is gonna generated, is not due to the change in the magnetic field lines. Now it is because of the motion of the conductor in a magnetic field line. So after the motion of the conductor in the magnetic field lines, how this conductor or how this rod becomes a battery? This is the aim of our video today. We will see how the motion of a conductor in the magnetic field lines compels a conductor to behave like a battery. Means what? After behaving like a battery, one side of the conductor will become positive, next side of the conductor will become negative, and due to the separation of the charge, there will be EMF generated in that. Okay, and that EMF will be equals to BVL, magnetic field strength, V velocity with which the conductor was moving, and L is the length of the conductor. So this formula is gonna generated after we will study today. So all the quantities B, V, L are mutually perpendicular to each other. Means one condition should be there, the in an angle between all the three physical quantities, that is the magnetic field strength or magnetic field and B, V, that is the velocity with which the conductor is moving, and the length of the conductor. It should, all these things should be perpendicular to each other. Mutually perpendicular means XYZ plane. So there are two methods of deriving this concept. Okay, one that is not given in the NCERT, and the second is given in the NCERT, and that was explained by the Faraday. Okay, so first we will study about that is not given in the NCERT for our knowledge, and in the next part we will study about the Faraday's law of explanation of E is equals to BVL, that is given in your NCERT. So let us start. So first part is the derivation, that is not given in the NCERT. What is happening? We have taken a conductor which is of length L, and the magnetic field lines which is going inside to the copy. Okay, that is cross I have made, and the conductor is moving with a velocity of V. Now zoom view I am taking. Zoom view means suppose I am taking at the conductor, and in that conductor, since the conductor is in means the I am talking about a conductor, so there will be a presence of free electrons. It is very obvious. And the another condition which we are supposed to take is BVL should be mutually perpendicular. So here you can see the B is going inside to the copy, V is here in this direction, and L is here. Okay, so XYZ direction means all the conditions are fulfilled. Now what will happen? See, if the electrons are there, okay, so there will be a force which we have studied in the Lorentz force, that force is F is equals to Q V B V cross B. Force on an electron means what? If the charge is in the motion, okay, and which is present inside the magnetic field, means which is also the magnetic field is also present in that region, and the charge is in the movement state, means a charge is moving with a V velocity. So for sure, whether it is electron or whether it is proton, there will be a force which is applied, or which will be felt by that charge. So in this condition, we are talking about electron. So in place of Q, the next formula will come, that will be E. So we can write F is equals to E into V cross B, or we can say that the V cross B is what? The sign product or the cross product we are doing. So in place of V cross B, what can I write? I can write the sign. So here you can see I have taken a sine 90. Why I have taken a sine 90? Because we have considered a situation that our magnetic field lines and the velocity should be perpendicular to each other. So as this condition is fulfilled in the diagram, so we are writing F is equals to EBB sine 90, and we all know that sine 90 is 1, so I can write down the force is equals to EBB. So here you can see, okay, where I have written, yes, Fm. Why I have written? Because it is the force due to magnetic field lines. Okay, right now we are not considering the electric field lines. It is only just the magnetic field lines because it is in the magnetic field. So that is why we have taken EFM. Okay, now the direction of this Fm can be find out with the right hand palm rule. Okay, and you have, for the right hand palm rule, what you have to do, you have to keep your fingers in the direction of the magnetic field lines. Okay, you have to keep your thumb in the direction of the positive charge motion. Okay, and in this condition we are taking a negative charge, so we have to keep the direction of the thumb in the negative charge. So where you will get the force, you will get the force in the direction of the palm. Okay, means in this condition if you will fulfill, you have to keep the fingers in your direction of magnetic field lines, means it is going inside. Okay, and you have to keep the electrons direction in the in negative, means it is going downward. If the current goes upward, so the electric field electrons always go downward. So if you will keep the palm, so palm is my palm is facing in the right hand side, so we have to direction of the force will be towards the right. So but we are taking talking about the electrons, hence that direction of the force will be opposite. This all be already I told. Okay, now after some time what will happen? Now after some time what will happen is the electrons are going downward. Why the electrons are going downward? Because of the Fm, the force of the magnetic field lines, which are the force which is felt by the electron, and due to the magnetic field lines the electron are pushed downwards, and as electrons are pushed downwards, so we can see the if the electrons are going downward, so it is very obvious that protons or the positive charge particle will go upward. So there will be, what will happen after some time, so there will be a separation of positive and negative charges in a conductor after some time. Why? Because when slowly the magnetic force will applied on the electron, and this process will be in a simultaneously, means slowly it will happen. Now we know that why I have written E here, because we know that if there is a separation in the charges and the electrons are going in a certain direction and the protons are going in the certain direction, so there will be a production of the electric field. We all know that electric field will gonna produce. Okay, now there, if the electric field is also there, then there will be a force due to electric field on the electrons. So we all know that F is equals to QE, means the force which is applied by the electric field on a charged particle. So we all know that F is equals to QE. Since we are talking about electrons, so in place of Q I can write down Fe is equals to QE. So hence with time, means what will happen, now there are two types of forces which are present. Fm, that is the force on the electron which is pulling the electron downward, and there will be force that is Fe, that is pulling the electron in the upward direction. Okay, why I have written Fe in the positive direction or in the upward direction? Because we know that the electric field always moves from negative to positive. Okay, so that is why the force will be towards like this. Okay, so after some time what will happen, more and more electron will reach bottom to the conductor and more charge accumulate there. Okay, because this Fm was already present, so this Fm is more dominating over the electrons, and what will happen, the electrons slowly will accumulate in the bottom. So now E will increase after some time. When the saturation of this point will come, now the electric field force will gonna increase. So when the electric field increases, the force which is applied by the electric field will also increase. Now one steady state will come. At that point of time, the force on the electron due to Fe and due to Fm will become equal. Means electron will be in equilibrium. In this condition, our electron will not gonna move in either of the condition. It will come in a equilibrium state. Now if our electron will come in a steady state, means what, Fe it will be equals to Fm. Now the forces which are applied on the electron will be equal in magnitude. So EE can be written as EBB, and in that case we can write down electric field is equals to V into B. Hence means electric field will be equals to V into B, means our electric field will gonna present in that conductor and which is flowing from this end to this end. Okay, so means we have studied ki the potential difference is equals to electric field into the conductor. So in place of E, just now I have derived, I can write down VB. So in place of E we have written BVL. So means the potential difference will which is created in this conductor in this case will become EMF is equals to BVL. Okay, and as the potential difference is created means the conductor is now having higher potential and having lower potential. So the E is equals to BVL can be seen as a battery. So this was the explanation which is not given in the NCERT, but it is for your knowledge. Okay, what the motional EMF is all about. And in the next video we will study how Faraday's has explained the motional EMF concept.